Fastest changeover in Latch-Up history. Steve. Excellent.
Yeah, all set to go.
Cool. All right. Ready, Carl?
Yep.
Do it. Cool. Thanks.
I'm Steve Hoover. I'm the founder of a itty-bitty little company in Massachusetts called Redwood EDA. Thank you all for coming to visit me. I've been waiting for your visit for 4 years now, since Latch-Up 2020 had to be canceled. So I'm going to be talking today about what's going on in the TL-Verilog ecosystem. Most of you in the room probably don't have much experience with TL-Verilog. You may have heard of it. You may have seen MakerChip, but probably not dug in deeply. And in particular, sort of give you that perspective on what's happening in the TL-Verilog ecosystem by talking about a program called Google Summer of Code. I've had several students over the past, I guess, 6 years in Google Summer of Code working on projects related to TL-Verilog, myself and other mentors. And FOSSi Foundation's been a part of that. And so I want to give this talk as a shout out to their involvement in that and to Google for sponsoring this program and sort of fueling the open source ecosystem with some actual dollars. So I'll talk about Google Summer of Code and FOSSi's role real quickly, and then just, we won't be going into TL-Verilog, but just to give you some perspective on what that technology is all about. And then I'll talk about 3 different kind of overarching projects within the ecosystem that have spawned some of the summer projects with the students. You'll meet the students and the mentors, and I'll spotlight a couple projects. So mostly this talk will be kind of a series of lightning talks on their work. So Google Summer of Code began in 2005 as Google awarding stipends over the summer to students to work on open source projects, giving fuel to the open source ecosystem, giving students wonderful opportunities across the globe that they might not have access to otherwise. FOSSi has, since 2016, acted as what's called an umbrella organization in Google Summer of Code. And basically, they act as the liaison between projects. And in large part, I want to expose you to this program. It's been great for me and my ecosystem, and it could be very valuable to yours as well. So FOSSi acts as the liaison between the organizations and, or between the projects and mentors and Google. So just a quick high level about TL-Verilog. The overall methodology and motivation for TL-Verilog, of course, productivity is all about abstraction. Hardware abstraction is difficult because you need control over the nitty-gritty details. So the goal is to benefit from abstraction without giving up on control, and the way we do that is to separate out in the model the behavioral specification from specification of how you're implementing that behavior. So you maintain control at the register transfer level as a designer, but the behavior is fully specified at a higher level that verification can connect to. So it's basically hardware features for the benefit of verification, which is where most of the energy, of course, is spent. And I'm taking a very incremental approach with it. It's very pragmatic and motivated by real industry experience. It's TL-Verilog and not TL because of the importance of integrating with the existing ecosystem, which is primarily Verilog in the industry. It's a very one step at a time kind of approach leading to a grand vision of better methodology. So one feature at a time, get that feature robust and working and valuable on its own. And it's about, I would say, 2 features out of 5 at this point. And I would say very valuable. Ultimately working toward new language. The work for this was seeded at Intel and carried out as an open source project, which in around 2015, I started carrying on as Redwood EDA. And we'll have a tutorial session tomorrow. I think that starts at 9:30 if I have it right, where in the course of 2.5 hours, you'll be able to learn the language, use the tools, or learn the tools, design a calculator circuit, and tape out that calculator circuit for tiny tape out. So I think that'll be a lot of fun. I hope you can join. So 3 projects overall, projects that I want to highlight in the TL-Verilog ecosystem. Every new HDL today needs a RISC-V core, so this is just a necessity. It has to be done, and so I did. So mine is called Warp-V. And mainly what it serves 2 main purposes, I guess. It's an exploration vehicle for features as they're developed. For me, you have to eat your own dog food. This is me eating my dog food. And it's really showcasing and exploring the configurability and reuse. So it's not really a core, it's a core generator. The next project is called First Class. This is started shortly after Amazon announced the F1 ecosystem. This is realization of the dramatic potential to change the computing landscape once you put programmable hardware in the cloud, accessible to everyone. One person in the open source community works on that platform. Anybody else across the globe has access to that hardware, which we've never had that in the past. And I think this is a key barrier in open source hardware. So exciting from the standpoint of access for people as well as access to software. You can integrate the accelerators into your web and cloud applications. But AWS was not doing anything to facilitate this beyond, oh, here's a new exciting compute platform. We're the compute platform people. We need that. So sort of out of necessity of things that I wanted to do down the road, spun this as a side project. It's not particularly tied to TL-Verilog. There wasn't any reason for it to be. But important infrastructure, and as it says, it's first class. It's not meant to be best class, but this is, let's get something in place. So this is infrastructure for facilitating FPGAs as accelerators in the cloud. And the third one here is the Virtual FPGA Lab, which is kind of a sub-project of simulation visualization. This is one of the key features on the MakerChip platform that's been valuable for open source hardware. And with this, so it's basically a framework for creating simulation visualization. So if you want to visualize the behavior of your circuit in a particular way, you don't have to develop the whole platform to do that. You can focus on the visualization. And one of the things we've done with that visualization is create a virtual FPGA lab. So just a screen cast of Warp-V. This is warp5.org, where you can go in, and this is a configurator for Warp-V. So you can come here and configure. Why is it not playing? Configure your core. You can configure the pipeline depth that you want. You can even configure the ISA that you want, the extensions. It has some support for multi-core. It's a bit of a work in progress, but you can do multiple cores. You can come in here and provide custom RISC-V program to load into the instruction memory. Open that up in the MakerChip IDE. So this is the code with the program that is stored in the instruction memory. And that will compile and build you that core. The visualization that I mentioned for this core is here. You can see the instruction memory, instructions executing out of the memory, being decoded, accessing registers from the register file, writing back register results. You've also got a cycle level view of the waveform diagram showing you register dependencies and other hazards. So that's Warp-V. First class, just some pictures behind what I was describing. It's allowing you to write software with call out to the FPGAs in the cloud to accelerate some function. So it's providing you this infrastructure to connect your web and cloud applications to the FPGA, right? It's just the bit streaming parts. And it's also the deployment infrastructure and development support for that model. Fractal Valley down here is a demo of that platform. So fractalvalley.com is hooked up to the FPGAs in the cloud. And you can compare, this is what it looks like running with C++. This is what it looks like running with FPGA in the cloud. And it's not actually publicly connected to the cloud just because of the charging, the billing that's required to support that, but the capability exists. And the last one here, the visualization and FPGA lab. So another screencast. A lot of this stuff is very visual. It's more fun to watch. This design is an AES encryption engine that was developed by some students in a course that I ran a couple weeks ago. They didn't create the visualization, but I thought their project was so cool that I went home and did so. So this visualization grabs a lot of the diagrams out of Wikipedia and brings them to life in simulation. You can see the behavior of the circuit and get a better understanding of the algorithm than you can looking through code. And then zooming out, you see the FPGA board that it was targeted to, and the impact that it has on the peripherals. These were the students that I've had since 2018. Great bunch of students, very energetic, and I think we've accomplished some great things. Also had some excellent mentors to support them. Of course, having good support for the students is key to their success in the program. A lot of other startup founders, professors, former participants in Google Summer of Code that have then come back and delivered or contributed back to the Google Summer of Code experience. So I think I have 6 projects to highlight. I'm not sure how I'm doing on time. The first one here, formal verification of Warp 5. So this is Akash in 2018. His project was focused on formally verifying, using open source tools, the Warp 5 CPU core, or, not core, but family of cores, so verifying all of them. So he was able to, over the course of the summer, get the whole environment set up and use the formal verification tools to do that for various configurations of Warp 5. So basically his work plugged in the RISC-V formal infrastructure, which is an open source package from Clairvolf, with the different hardware configurations. And usually when you have a student working all summer long and all they do is write a page of code, you get pretty upset about it. I was overjoyed. We demonstrated the feasibility of doing all this with very little code. And then the quote there that I really appreciated on LinkedIn. Ahmed, same year, worked on furthering the development of a component library, very much a work in progress, but he made good headway to showcase the, really, I don't know, if you had asked me 20 years ago if top-down design was feasible, I would say no, the industry gave up on that. That's never going to work. And then over the years, I've realized, holy crap, that's feasible. And that's kind of what I've been driving toward. And this is kind of our first demonstration of the feasibility of that methodology, that approach. So with this generic component library, Ahmed was able to put this together, demonstrate a microarchitecture, and then fill in details in that microarchitecture and show that you can represent that diagram on the right just by instantiating a few components and then further integrate the details into that framework. And his work, I forgot to mention in Akash's work was showcased on, well, subsequent to his work, we did a paper together published on arXiv. His work was featured in SemiWiki. He presented at ORConf, VSD Open, and then I presented his work at the Boston Area Architecture Conference. So this work is reaching people. Ahmed's work also was published with me on arXiv. First class, so Akash picked this up, did another summer with me the next year. He was picking this up sort of after we had done basically proof of concept, putting the pieces together, but Akash really polished it, made it a generic library that other people could use and leverage, automating the provisioning and deployment. He also developed support for local development of your hardware kernels, of course, using open source tools, and versus what you can get from Xilinx in the cloud to do the same thing. Just unbelievable performance improvement that, as we were discussing earlier, I can't share, but I wish I could. Akush's work that year was featured on the Google open source blog, and this work, first class, was picked up by the Open Source FPGA Foundation, which has now been merged with ASIC Alliance. Ninad's project, 2021. Block-based circuit design, so I'm sure many of you have, certainly anybody with kids that are technically minded have seen MIT Scratch, enabling small children, my own children included, to learn software far earlier than I was able to do so. Using blocks, very little typing to be able to program point and click. We thought it would be fun to apply that to circuit design, and so basically Ninad translated TL-Verilog to blocks. And we had a nice proof of concept there. Bala worked on the virtual FPGA lab, so you kind of got a piece of that already, but that's creating this virtual environment where you can see how your circuit is impacting the LEDs and whatnot on the peripheral. Bala and Ninad both got honorable mention at U-Booth at DAC for their work, which is pretty astonishing. I mean, generally this is awarded to PhDs who have been working on their project for much longer. And this was also picked up by OSFPGA. Vineeth worked, what's my time? All right, so Vineeth worked on basically combining first class and Warp 5. So he worked on stabilizing the many-core implementation of Warp 5 and then deploying that onto the FPGAs in the cloud. And this gives you a framework where you can quickly configure a many-core CPU accelerator the way you want, provide custom instructions, and deploy it to the FPGA as an accelerator and kind of explore things that way. We've had many other projects related to Warp 5 first class visualization. We had a tensor core project, somebody working on various flows for the TL-Verilog ecosystem together with other tools. Just to emphasize, the program is very valuable for the students, giving them opportunities. Obviously, these are all very bright students that are very motivated and had a bright future ahead of them. But I think they would all tell you that this opportunity over the summer was a great lead into next steps. So Google Summer Code is awesome. The students are awesome. If you give bright students the opportunity, they can shine. And Google Summer Code is a great example of that. Of course, TL-Verilog is my own technology, so of course it's awesome. And I don't need to argue the last bullet with anybody here. So with that, I'll take questions.
All right.
Hello. FireSim plus TL-Verilog sounds extremely interesting.
I agree.
How did you? Can we get that out so that it's it feels to me like FireSim is sort of stuck in this chisel world, and we can't haven't been able to get it outside of chisel.
We actually, we had trouble moving forward in the direction that we wanted to move with that project, and it kind of redirected, so we didn't make good headway on the goal, which I really think would be awesome. FireSim is an amazing framework for focused on simulation acceleration using the cloud FPGAs. But unfortunately, I don't have much to say about it because we ran into some trouble. Yeah. And don't take that trouble as there's anything wrong with FireSim. It was more about the organizational trouble.
Questions? I just wanted to thank you on behalf of the FOSSi Foundation for your participation in GSOC as a mentor every year. It's been fantastic. You've been one of the longer running kind of participants in that, and clearly the outcomes have been
Super appreciative of that.
Yeah, so
Great opportunity.
Absolutely. So with that, thanks very much, Steve. Thanks for coming along today.
Thank you.